Hello, and welcome to the NetAlly LinkRunner AT 2000 training. My name's Mike Pennacchi, and I'm going to be your instructor. So what we're going to do is we're going to go through the functionality of the LinkRunner AT in depth in this webinar. So what I'm going to do is go through and start by talking about the difference between the LinkRunner AT 1000 and the LinkRunner AT 2000. With the LinkRunner AT 1000, it has a 10-100-1000 copper interface on there with an RJ45 connector. This can go in and solicit PoE, so it'll tell us if PoE is present on the port. We can get information about the nearest switch. This supports CDP and LLDP. And I'll tell you, when it comes down to figuring out where a wall jack is connected, this is such a nice feature. That alone, just being able to go in and see what port is this wall port connected to, huge time saver. We can get a link, we can get a DHCP address, we can find our default gateway, we can even go in and set a static address on here. In addition to being able to link to the network, it has some cable test capabilities. We can measure the cable length, and we can take a look at a number of different cable problems, which we'll go through in here. We can ping up to 10 targets. So we're going to see how we can go in and add these targets. This is a great way to validate that you have the connectivity that you want on your network. It supports 802.1x authentication, so if you're using that on your network, this is supported. We can do toning. We're going to look at how we can do that, both analog and using the Fluke Networks IntelliTone. And we can connect this in with Link Live. We'll get to Link Live a little bit later in this presentation. Now, the LinkRunner AT 2000, and this is really the one we're going to be focusing on and using in class the most. The difference with the LinkRunner AT 2000 is that it supports true power. Now, what's the difference between soliciting PoE and true power? When we use true power, we're actually drawing that amount of current. This allows us to ensure that that switch is able to provide the class of service that we want. We'll do a little work with PoE and take a look at that. It has a 100/gig SFP interface for connecting to copper. We can put in either multi-mode or single-mode SFPs in here, depending on what type of network you're working with. It'll act as a 1 gig reflector. So if you have a tool like the Etherscope NXG and you want to do a throughput test, there's a couple of different options. Well, in the performance test in there. And with the performance test, we can have peers and reflectors. This is a reflector. One of the great advantages of using this as a reflector is that it will reflect full line rate, full duplex gig without any packet loss. And it comes standard with a lithium-ion battery. So if we came up to the top and we looked at our fiber port, we see that we've got that SFP slot in there. And one of the questions that comes up oftentimes is, what SFPs do I need to use with this? And what I've found is that pretty much any SFP I've plugged into it has worked. In fact, if you want to truly validate a connection, plug the SFP into this, test it, and then take that SFP out and plug it into the piece of equipment you're deploying. This is a great way to ensure that that SFP is working. With the proper SFPs, and it really depends on the functionality of the SFP, we can go in and measure optical signal strength. We'll talk about that, because if our optical signal strength is too low, we're not going to be able to establish a connection. So this is a great way to validate that we have enough optical signal making it to the far end of the fiber to support a connection. And we can reflect traffic on the fiber port, so we can use this for testing throughput on our fiber links as well. On the side, we have a wire map port. So sometimes we just want to make sure a patch cable is good. So what we'll find is that we can plug one end of the patch cable into the wire map port. We can plug the other end into the port on the top, and we can do a wire map. This is going to tell us how long it is and let us know that everything's working okay. And when we get into our cable testing, we're going to look at the difference between an open connection and one that's been terminated using a wire map adapter or the wire map port. It's going to show us a few different things, some things that we can't tell just by testing an open connection. There's a USB port on the side of the LinkRunner AT. So this port allows us to use LinkRunner AT Manager in conjunction with the LinkRunner AT to download reports, transfer profiles to and from the PC, and to do firmware upgrades. So we're going to use that to communicate with a Windows PC running the LinkRunner AT Manager software, which can be downloaded from the NetAlly website. There's a power port. Now your LinkRunner AT2000 came with a 15-volt power supply. When we connect that up to the battery pack there that's got the integrated charger, the light is going to be red when it's charging and green when it's fully charged. So if you have the LinkRunner AT2000, this has the charger integrated right into that lithium-ion battery pack. All right, so enough about the LinkRunner AT physical overview. Let's get in and start looking at some of the features. So in this case, we're going to look at the switch tool. So if we come over here and we flip over to our LinkRunner AT2000, here we have the main screen. And if we back out just a little bit, what we're going to see is that we have our buttons down here, our arrow buttons, our select button. We've got a back button, so we can go back to a previous screen. We've got a refresh button. We've got a save button, home, which is a great way to get back to the screen we're on right now, and F1 and F2. And what you'll see is that right above F1 and F2, we'll have different things appear like, I want to save this, I want to start this, etc. So in this case, what we're going to do is we're going to zoom in here and we're going to arrow up to our switch test. And I'm going to hit switch and it's going to run a test. Now, right now, I don't have any cables connected up to my LinkRunner AT. So what I'm going to do is I'm going to grab an Ethernet cable here and I'm going to plug that into the copper port up there on the top. We'll come back to the screen, and when we do, what we see is that this has given us some information about what's going on. It tells me which switch I'm connected to, which port I'm connected to, that I'm receiving an Ethernet signal, and that I'm getting PoE. So let's go through what this screen is telling us in detail so that we know how to interpret that. So if we come over here and we look at our switch information, what do we get? This is going to give us speed and duplex. It's going to tell us if we have PoE. It's going to tell us which Ethernet pairs are used, if our signal is good, and if we're connected to an optical connection, what our optical signal strength is. Speed and duplex. It is critical that we know what speed and duplex is being provided by the switch that we're connected to. So in this case, we can see that this switch is telling us it can do 10, it can do 100, it can do gig, it can do half duplex or full duplex. Now, those speeds, the speed in bold and the duplex in bold, are what we negotiated. So this tells us we negotiated gig full, and that's exactly what we'd want out of a connection like this. Now, let's do this real quick. Let's flip back over to our LinkRunner AT. I'm going to move this to a different switch port. So I'm going to unplug the connection. We see that we lose connection there. I'm going to plug that in, and let's see what we get. In this case, we see that it says this is set to 100 half duplex. Well, that's no good. We don't want 100 half. We want gig full. So what's happened here? Well, what happened in this case is somebody has set this port to 100 full. They forced the speed and duplex. And it's outside the scope of this presentation, but you force a port to 100 full, you are going to get 100 half on the other end. It's how the negotiation works. So this is a great way to go in and ensure that we're getting the speed and duplex that we expect out of our connection. So duplex, same thing, right? That we're going to see what's advertised by the switch. And this is going to happen if we're auto negotiating. So again, in the example we have up here on the screen, we're saying that the switch can do half or full duplex, and it can do up to a gig. CDP LLDP information. So this is a protocol where it is sending out packets from the switch that contain information about that switch. So the protocols that are supported by the LinkRunner AT are the Cisco Discovery Protocol, the Link Layer Discovery Protocol, the Extreme Discovery Protocol, and the Foundry Discovery Protocol. Now, we may not see too much Extreme or Foundry out there anymore, but CDP and LLDP are very popular protocols to use to display the information about the switch to which we're connected. Now, if we go in and we take a look at this information, we're going to be able to see the name of the switch, the model of the switch, the IP address, and the port number. This will save you the effort of crawling underneath the desk and trying to look up there in between the back panel of the desk and the wall to see what the jack number is. And then going to the wiring closet and finding that jack number, tracing that cable out, and finding the port and switch to which it's connected. This tells us right here which port and switch we're connected to. This is a great way to know exactly what address we need to connect into to change any configuration on this port. Also, when this information is uploaded to Link Live, we can put in the wall jack number as a comment, and we can use this to create documentation that maps wall port to switch port. So now if somebody has a problem at that wall port, we know where it was last connected. Fiber signal strength. So what we're going to do is we're going to come over here, we're going to move from our copper port to our fiber port. So I'm going to disconnect the copper port right here. I connect up a fiber connection to the same switch. So what we see on the screen right here is that we've got our fiber connection. It tells us that our optical signal strength is 7.75 or 7.6 decibel meters. Now, decibel meters is a measurement of optical signal strength. So this gives me an idea of how strong that signal is coming from the switch. Now, about the best I'll ever see in here is right around -6 decibel meters. This value needs to be greater than -18 decibel meters. When I start getting into the -18 range, that is not a strong enough signal to support a gigabit connection. So if you've got a fiber connection, you want to make sure that there's not too much loss on that connection to support a valid TCP connection or a Ethernet connection, then use this to measure what that optical signal strength is. So in our example here up on the screen, we can see that we're at -7.04 decibel meters. That's great. That's a really good signal. Now, it is a good practice to always clean your fiber, both the fiber end face and the SFP. There's a variety of click cleaners that are available out there. It helps keep from damaging the fiber end faces and damaging your SFPs. Flashport. So there are times where we are working with a switch that does not send out CDP and does not send out LLDP. I was working on a little project and they had an unmanaged switch. So I was unable to tell where I was connected. So what we can do here is that we can select Flashport on our switch port screen and we can tell it to flash that port. And the link light will turn off and on and off and on. We can come in and using our arrow keys, left and right arrow keys, set the speed of that. So now when you look at that switch, other lights may be blinking due to traffic, but you'll see this one that's going off and on at a very constant rate. This is a great way to locate those ports. So whether you're getting CDP and LLDP, or you've got an unmanaged switch where you need to be able to flash that port, using the switch tool on the LinkRunner AT gives us the ability to do that. Our cable test. So being able to verify, validate that the cable is working as it should is important. So what this does is it allows us to do a wire map of the cable. It'll measure the length of the cable, it'll test the wire map, and it will give us the length to faults. So if there's a broken conductor along the way, it'll tell us where that is. And we can go in and we can use wire view adapters at the far end, and I'll show you those when we start testing our cable, but these are available. We can get them with various numbers on them, and we can use that to help identify cables out there at the far end. So one of the easiest tests to do is just to do an open-ended test. So if I come back here to the bench and I grab some cable and I plug that cable into the Ethernet port on my LinkRunner AT. So I'm going to plug that cable into the copper port. I'm going to unhook my fiber port here. We're going to hit the home button. We're going to come down to cable. We're going to run a quick open-ended test. So this open-ended test tells me that my cable is 104 feet long. Now a good example is the one that we have up on the screen here, where we can see we've got 151.8 feet of cable. Now, this will give us an idea if that cable is broken anywhere along the path. What an open-end test doesn't do is it doesn't tell us that the connector at the far end is good, because the signal is just going out the end of that cable. Great way to tell if this is connected to a device at the other end or if the cable's open. In fact, let me just show you real quick. I'm going to plug this into an active device here. And we're going to switch over. And I'm going to run that cable test again. I'm going to hit the refresh button. Now in this case, we see that there's a switch there. So if I run the cable test and I see a switch right there, hey, that tells me this is plugged into an active device. Okay. So we'll unplug that from the active device. We'll come back here. Tone. So let's say we're trying to trace out a cable. We want to get an idea of where that cable runs, or nothing's documented properly, so we need to identify that. Now we can use this with an analog toner, or we can use it with the Fluke Networks IntelliTone. So if I come over, I've got my cable right here, and I'm going to refresh my test. And I'm going to hit the tone button. So it's going to start sending out, I'm going to hit start test. It's going to start sending out a tone. So here I grab my Fluke Networks IntelliTone. And in this case, I'm using the 200, which has an RJ45 connector on the bottom, and I'll show you what is nice about that. So I'll turn that on, and I'll move it over here, and we can hear that it's picking up the signal. And on the IntelliTone, I have some LEDs right here that let me know how strong that signal is. Now, once I get to what I think is the correct cable, I can flip over here to wire map. And I'm going to plug this into the RJ45 on the end of the IntelliTone. And what we notice is that our LEDs are lighting up right there on the IntelliTone. I'm going to do that again. I'm going to plug that in. And my LEDs light up, letting me know that each conductor is good. So using the IntelliTone, not only can I help locate where that cable is, but from the far end I can see that my conductors are good and I'm connected to the right cable. So this is a great way to be able to go in and map out cables if we don't have things like CDP and LLDP, or the cable's not connected to anything at the far end. Now, let's go ahead and take and connect this to the wire map port and see what happens. So we'll come over here. I'm going to stop my toner, and I go back, and I connect this to the wire map port, and I'm going to hit refresh. I'm going to rerun that test. Does our wire map. It draws a nice little picture in there of the cable coming back and connecting to the wire map port, and it tells me how long the cable is. Now again, what this does is this allows me to ensure that that connector at the far end is working properly, that's wired up properly. If we had a case where that connector out there at the very far end, one of the pins wasn't connected properly, we wouldn't see that with the open-ended test. Now I mentioned wire mappers. So we can get wire mappers with numbers 1 through 6 on those. Now what these work well for is if I can't get to both ends of the cable in the same location with the LinkRunner AT, I can put a wire mapper out at the far end and use this as a terminator. Also, the LinkRunner AT 2000 or the LinkRunner AT is going to show me which wire mapper I'm connected to. So let's do that. Let's come over and we are going to connect wire mapper number 4 to the far end of this cable. So there we have wire mapper number 4 connected. So I hit refresh. It refreshes that. And it shows us wire mapper number 4 out there. So if I was keeping track of which ports I plug these into, I could use this to map out my cabling. So this tells me all my pairs are good. In the case we have up here on the screen, it tells me my cable's about 152 feet long. I can plug the wire mappers into the patch panel, or I can plug the wire mappers into the jacks out there in the offices, write down which jack I plugged it into, go back into the wiring closet, and connect up my LinkRunner AT and see what wire mapper I'm connected to. So faults detected. When we're connected out there to a wire mapper, we can detect things like opens, rolled pairs, and split pairs. So an open. In this case, what we're seeing here is that pair 7-8 is open at less than 3.3 feet. This is probably a problem right at the jack. So in some cases, older wiring, we ran into examples where people wouldn't connect up the brown pair 7-8 because the link was either being used for voice or it's being used for Ethernet, and they didn't need 7-8. They never hooked it up. Very lazy workmanship. But in this case, this would help us identify that, and it tells us that those pairs are broken at the near end. Now, if we want to be able to detect that those pairs were not connected at the far end, we would need to use a wire mapper at the far end. Rolled pairs. So this case, somebody got the pairs twisted around on one of the ends. Now, since Ethernet uses a differential mode signal and AC, it does not depend on polarity. We can have the pairs rolled like this and Ethernet will still work. But it's not good practice. So in a case like this, if we connected up and we saw this, we'd want to go back and inspect the connectors at both ends and see which one was wrong. Unfortunately, we can't tell looking at the wire map right here which end is having the problem. Split pairs. This is a case where somebody didn't follow the TIA 568A or 568B wiring standard. What they did was they ended up taking and splitting some of the pairs, some of the pairs that are defined by the wiring standard across the physical pairs in the cable. Now, one of the reasons we use twisted pair cable is to ensure that we are canceling out interference. If we split a pair for 568A or 568B across two physical pairs, we end up with two physical wires running in parallel to each other. This creates a significant amount of crosstalk and creates problems with the signal. So if you see split pair, it's time to go back and look at the wiring on the jacks and see what's wrong. Somebody didn't follow the wiring standard. All right, so that takes us through how we go in and do some of the testing as far as our cable testing goes. So now let's go in and take a look at auto test. Now what I find is auto test is one of those things I use constantly. I love how fast the LinkRunner AT starts up. In fact, if I just want to see what subnet a port's on, I will go grab my LinkRunner AT, plug it in, and do a test. I've got all this other equipment available to me. I got to say, when it comes to just checking a port out, that LinkRunner AT works pretty well. So it's going to allow, this auto test is going to allow us to measure the PoE voltage, the link characteristics. So, what's going on with this link? We can go ahead and get a DHCP address, or we're going to see we can configure a static address. We can run tests to things like our DNS servers and our default gateway. We can test a predefined set of targets using either ICMP echoes, pings, or send a TCP SYN packet and see if that port is open on that device. So let's start with PoE. PoE we're finding is becoming more and more popular for lighting. There's some controllers I use for controlling the lights behind me. In fact, I just put in some nifty LED strip lights underneath there. Now, the controller for those LED strip lights in some cases can be powered using PoE. So if somebody's setting up a large stage or something, you don't have to run power to that device. It's used for cameras, it's used for access points. So we want to make sure it works. Now, one of the great advantages of the LinkRunner AT2000 is true power. And what we're going to see is it will actually draw the power and tell us whether it will support the wattage or the class of service that we're looking for. So when we run auto test and we have PoE enabled, what's going to happen is we are going to solicit PoE. So here we can see that our positive is coming through on pair 3-6, our negative on pair 1-2. PoE actually uses both conductors in a pair for positive or negative. We requested 13 watts, we got 13 watts. Our unloaded voltage, and this is our voltage before we applied the 13 watt load, was 51 volts. After we applied the load, it was 50. So this can be a good indicator if we have cable that is substandard, copper cladded aluminum. We may see our voltage drop so low that it's not going to support being able to connect at that current. Okay? So we're going to be able to see what type of device it is, whether it's a type 1 that supports up to 15 watts or a type 2 that supports up to 30 watts. Now, in order to use our PoE in our auto test, we need to configure PoE. So this is where we're going to go into Tools on the LinkRunner AT. We're going to arrow down to the PoE configuration and we're going to hit Select. When we do that, we can come in and enable PoE. Now it says copper only. It'd take quite a voltage to run PoE across fiber. But in this case, we're going to enable PoE. Now that will solicit PoE and show us what the voltage is without putting a load on it. If we want to put the load on it as well, then we're going to check Enable True Power and select a PoE class. So in this case, if we select class 0, it's going to attempt to draw 13 watts of power. Now here's a case where true power failed. So here we see that we solicited power and our unloaded voltage was 51 volts, which would appear to be okay initially. However, once we put that 13 watt load on the end of that cable, what we saw was we only received 2 watts. This tells us that somewhere along the link we have a problem. So this could be copper cladded aluminum wire, this could be resistance at a connection, but this right here would tell me that PoE for the class I need is not going to be supported by this particular switch or this particular link. So just as some information on PoE classes, what we see is that the LinkRunner AT2000 supports up to class 4. So with class 4, we can draw up to 25.5 watts of power. So that's pretty good. Now here we see that that is at the PD, and that's the powered device. So that's, and PSE is power source equipment. So just anytime you see PD, that's the far end of the connection. PSE is the near end of the connection. So before we move on from that, let's come over and let's do a little PoE testing. So we're going to switch over here to our LinkRunner AT2000. I'm going to unhook it from this cable right here, and we'll set that back on the bench. And I'm going to grab my Ethernet cable. I'm going to move back to that port that isn't misconfigured at 100 meg full. We're going to plug in. And I'm going to go back to my home screen. I'm going to come over to Tools. I'm going to make sure that I've configured PoE the way I want it. So I've enabled PoE, and I've said that I want class 0. So I want the class 0 13 watts. So I'll hit Save. I'll go back to my home screen. I'm going to come up to Auto Test. I'm going to run my auto test. So we establish a link. It tells it's going out and getting our switch port information. And right up here at the top, it shows us that we've got our 13 watts. Our voltage is 47 volts. That is perfect. That's exactly what we'd want to see. Now, if we come down, I say, you know what? I really need class 4 PoE. So what I'm going to do is I'm going to go back to my home screen. I'm going to go to my Tools. I'm going to go to my PoE configuration. I'm going to set this to class 4. Okay, and I'm going to hit Save. Go back to my home screen. I'm going to rerun that auto test. So for this particular situation, I need to make sure I can get class 4. I need to get up to 25 watts of power. So let's go back over and see if we got that. So in this case, we look at our PoE and we see it failed. So we only got 16.5 watts when we requested 25.5. This switch connection will not satisfy my needs. So what I'm going to do is I'm going to unplug that. I'm going to plug into a different switch. Let's say I rework that and I say, I'm going to plug into a switch that provides a little bit more PoE. So we'll let it run its PoE test. Hey, there we go. So we got our 25 watts of power right there, 54 volts. That's a good looking connection right there. So what this does is this shows that I can go in and validate my PoE to make sure that that power over Ethernet is giving me the voltage and the wattage that I need for that connection. Without true power, there's no way to assure that. So that's how we go in and test that. LLDP negotiation. When it comes to class 4, the LinkRunner AT2000 will support LLDP negotiation. This is where it's going to use LLDP frames to inform the PSE, the power source equipment, the switch, what type of power it needs in there. Our link information. Now we saw this a little bit when we went through the switch test on the LinkRunner AT2000. And here it's telling us what our connection looks like. So what's the advertised speed, advertised duplex? So in this case, we connected a gig full. The switch is advertising that it can do gig half, or it can do half duplex or full duplex, 10, 100, 1000. So we know it's set to auto negotiate, and we got the speed and duplex we wanted. So that's great. That tells us we've got a good connection. Next is and we can come in here and we can force those in our connect configuration. So if we wanted to change our speed and duplex, we could go into our tools, we could go to connect configuration, and here is where I can go in and I can turn on my security, my 802.1x authentication. Now, for 802.1x to provide the credentials necessary, what I'm going to need to do is set that up in my LinkRunner AT Manager software on my PC. Connect my PC to my LinkRunner AT using the USB cable and transfer that over. We're not able to put those credentials directly into the LinkRunner AT. Speed and duplex. Just set it to auto. Really, I mean, I still run into cases every once in a while where somebody is using forced speed and duplex. It is nothing but trouble. So leave it to auto, but if you are in an environment where you absolutely have to set the speed and duplex, go into tools, go into connect configuration, and this is where we can set our speed and duplex. Receive pair. So in this case, what we find is that for gig, we need all 4 pairs. So right here it says receive pair all. So this tells me I'm receiving on all the pairs. When I use gigabit Ethernet, I'm transmitting and receiving on all 4 pairs. But remember that example we showed when we did our wire map where pair 7/8 wasn't there. Somebody didn't connect it up. Well, that means we don't have all 4 pairs. If we don't have all 4 pairs, we can't do gig. So if I plugged into a connection and I noticed that I was only connecting at 100 full duplex. If I'm connecting at 100 full, it tells me that the switch isn't forced to 100 full. And that there's a really long story that goes behind all that. But if I'm getting 100 full, that tells me that the switch is probably auto-negotiating or it's advertising 100 full. And here we see it's advertising 10, 100, half or full. So, and my receive pair is only 1, 2. So if I plug in and I see something like this, this is a good indication that not all the pairs are there. So the first thing I would do is I would go in and run a wire map to make sure that all the pairs were good. Okay. So if I'm expecting gig full and I get 100 full and I see my receive pair is only on 1, 2, now it's time to go back, do a wire map to find out why all 4 pairs aren't there. Polarity. It tests the polarity of the pairs. If we see that the polarity is reversed, this could be that there are rolled pairs. And again, good time to do a wire map with the LinkRunner AT. Level. So level gives us an idea of what the voltage level is of our fast link pulse that's used to advertise the speed and duplex, and of our data pulses. So in this case, if we see that our level is low, this could be an indication that we have high resistance on the cable's over length, or there's something wrong with the transmitter. So for this, we want to see that level normal. That tells me that I'm getting a good signal coming in from the far end. Okay. And advertise. We've hit this when we looked at the switch information. This is what the switch is advertising. This switch is telling us it can do 10, it can do 100, it can do gig, it can do half or full. So it's telling us what capabilities that switch has. Now here's kind of a neat little piece. I don't have to plug this into a switch. I can plug this into a printer, a PC, a camera, an access point. What this will do is this will decode what the other end is telling me. So if I have a printer that just isn't connecting up, maybe that printer is only capable of doing 100, but somebody set the switch port to gig. And in that case, they're not going to talk to each other. So I could plug it into the switch port, hey, it's only doing gig. Plug it into the printer, it's only doing 100. That's my problem. So I can use this advertise as a way to figure out what each end is advertising, and this can tell me why they may not be connecting. Switch port, we saw this information when we took a look at the switch test. This gives me the name, the port, the model, and the IP address of the switch. Nothing is faster at figuring out where that wall jack is connected than going in and looking at this information. Now here's the really cool thing. If we claim our LinkRunner AT to link live, when we run this test, we can go in and you notice down there in the bottom right it says comment. We can push F2 right underneath that and add a comment. And if I put in the jack number, it's going to tie that jack number to that switch and port. So if somebody calls up and says, and we can add comments for office, building, floor, person's name, anything. So if that person's having problems in the future, all you have to do is go into Link Live, type in that wall plate, type in that office number, it'll come back and tell you the switch and port that that's connected to. You don't have to go back out there. This is especially useful for remote sites. So if you use the LinkRunner AT to go in and validate connections as you're putting them in, and you put that wall jack in there, you are now documenting which wall plate is connected to which switch port, and you will have that stored in Link Live. This eliminates that need to go in and trace out cables. IPv4. Once we have PoE and once we have a link, we need to get an IP address. So this is going to show us the IP address that was given to us by DHCP. Now we'll look at where we can go in and configure the LinkRunner AT to use a static IP address. So if you're on a network where you're not running DHCP and you're not providing a DHCP address, we can go in and statically configure that. So if I go into my tools and I go into IP configuration, this is where I can go in and set that up. So here we've selected our IPv4 tab. And I've said, go ahead and use DHCP. Automatically get an address. And again, if you're not using this for validating every connection that you're hooking up, you're making a big mistake. This will let us know that we're getting the proper address. We're getting an address in the right subnet before we turn this over, right? And I don't want you to use the S word, and that should. I want you to be definitive. We've tested this, and we know it's working properly. So here I've set my IPv4 configuration to DHCP. Now I could set it to static, and if I set it to static, I can configure the IP address, the subnet mask, the default gateway, and up to 2 DNS servers. Now here's the neat thing. These configuration settings can be saved in a profile. So I could save a profile that I always use on this network. So I don't have to go back in and reconfigure this static information. Once we get this set the way we want, we're going to look at how we can go into files. We can go into save this profile. We can save it. So now the next time I go out to this location, all I have to do is load that profile and I'm all set to go. IPv6. The LinkRunner AT supports IPv6. So if I enable IPv6, it will go out and try and get an IPv6 address. So here we see that we have both our link local address and we have our global address, which was provided to us by by the router. So this is a great way to ensure that we're getting a IPv6 address if that's something that we expect in our environment. So now with DHCP, here we're seeing that we got our offer, we received our ACK, we're connected up. So how does DHCP work? We send out a DHCP discover. That DHCP discover is picked up by the DHCP server. It grabs an address from the pool, sends it back to us, and says, hey, here's an address I want to offer to you. We send a request. You know, I kind of like that address. And so we request the address. It sends us an ACK. That address is yours. And it gives us information like our subnet mask, our lease time, our renew time, our default gateway. Tells us which server provided that address. Now, what can cause DHCP to fail? First one is not getting an offer. I go, hey, I want a DHCP address. Crickets. Ooh, that's bad. So what can cause this? Well, it could be that there's not a path between where we're at and the DHCP server. That could be one problem. Another problem could be that the DHCP server has run out of addresses. So this is one that we see. If the pool has been exhausted, we won't see an offer. So what I need to do is figure out, hey, which one is it, right? So the first thing I would do is I would go check my DHCP pool and see if I'm out of addresses. And if I am, I got to go fix that. If I'm not, then I would look at the path between the LinkRunner AT and the DHCP server. Here we see that we've got a duplicate address. So we were given a DHCP address, but it comes back and says duplicate. What happened here? Well, this could be a case where another device is using the same IP. Somebody just grabbed an IP address and configured it on a device. So when we get a DHCP address, one of the first things we do is we go out and we send an ARP. Is anybody else using this address? And if we get a reply, you see a message like this. So this tells us that somebody else is using that IP address, and that's bad. Somebody has statically configured an IP address that falls into the middle of a DHCP pool. That causes problems. So in this case, we'd want to go out and find where that IP address is, where that device is, and either assign a static DHCP address or put them in a portion of that subnet where that address can be statically configured. Here it gives us our subnet mask. This is important because if we're using the wrong subnet mask, we're going to have a hard time communicating on our network because our subnet mask sets our broadcast address. So what we want to do, make sure that the subnet mask that's being handed out by our DHCP server is consistent with what we expect for that subnet. Now the I right there, we see there's an I that is informational. This isn't a pass-fail. We haven't told it must be this subnet mask. So it's giving us this information. You see other things have a check mark. That is a pass-fail. So we can use those as a way to determine, did this work properly or not? DHCP server. This tells us the IP address of the server that gave us the address. Now, in a healthy, normal operating network, we may have redundant DHCP servers. So we can see which of the servers gave us the address. I've been around long enough that I've seen plenty of people bring routers in from home. I just need a few more ports under my desk. So they're going to do a little networking because how hard could it be? It's an RJ45, you just plug it in. So they take that router from home, plug it in, and plug some other devices into it. Problem solved. But all of a sudden, everyone around them starts having connectivity problems getting out to the network. So we go back and then all of a sudden it's our fault, right, as network administrators. But when we go out and try and get a DHCP address, what we notice is we're getting a 192.168.0 address, and we've got some server in there that's 192.168. This is a good indicator that somebody has placed a router or another device that's handing out DHCP on our network. So knowing what the server is, really good information for us. Now, if we are doing IPv6, here's where we can go in and see our IPv6 information. So here's our IPv6 link local address. So when it comes to v6, we have a link local address. This is an address that is only valid in our broadcast domain, and the address is generated based on the MAC address of our device. So this is used to communicate within the same broadcast domain for two devices running IPv6. Global. This indicates that it received a router advertisement and told us, hey, there is a you can use a global IPv6 address. So this is the kind of address that will allow us to route through the internet using IPv6 to sites out there. So if we're expecting an IPv6 address, we're going to want to, and we want to get off of our local subnet, we're going to expect to see an IPv6 local address. Targets. This is great. We've gotten out there, we've gotten an address, we've got a link, we're getting the PoE we want, so now we want to be able to get off of our network and make sure we have connectivity to the resources we need to get to. So by default, we are going to put in targets of our default gateway and our DNS servers. So here it's tested connectivity to our default gateway, it's tested connectivity to the first DNS server and the second DNS server. And that's important because I've been out to sites where one of the DNS servers didn't reply. I said, I bet you things are slow, aren't they? Yes, they are slow. Well, why are you still handing out this DHCP server? It's not responding. Oh, we de-implemented that. Well, maybe you should have taken it out of DHCP first. So in this case, we want to make sure that those DNS servers and default gateway are responding. This means we can resolve addresses, we can get off of our subnet. Beyond that, I can put in up to 10 devices out there, IP addresses, DNS names, to test. I could put in websites, email servers, domain controllers, voice over IP servers, anything that somebody needs to get their job done. Now, in this case, we have done a TCP connection using port 80 out there to get to netally.com. So we can either ping it or we can test the TCP port to make sure that service is working. So when I go in to add a target, I go to Tools and I go to my Auto Test Configuration. Here I can enter in my targets. So I've put in www.netally.com. I said test port 80 on that. Then I put in my email server and I said test port 25, and then I put in the email server with no port. Now if I don't put a TCP port in there, that is going to do an ICMP echo test. It's going to do a ping. If I put a port in there, that's going to do a TCP connection. So if I can't get to port 25, but I want to be able to test and see if I can get all the way to that server, I can do that. Okay? So we put in a port, it's going to do a TCP test. We don't put in a port, but we only put in the IP address or DNS name, it's going to do an ICMP echo. Now, for each of those targets that I test, it is going to run 3 tests. So here, we've gone out, we've tested port 80 to netally.com. And we see that our response time, 72, 72, 70. That's pretty consistent. Here, SMTP, so that's port 25 to our email server, 60, 60, 58, quite consistent. In fact, all these, 80, a little bit up there. But this gives us an idea of what the round trip time is to that service. So by going in and running this periodically, we get an idea of what's normal. And that goes back to doing network health checks and knowing what our network looks like when it's operating correctly. But if I saw that these values were really high or I saw packet loss, that could indicate that if we're going to go out and use those resources, That can be slow. Comment. Now there are two different types of comments that we can add in here. And one is a job comment, and the other is a comment for each test. Now if we go in and add a job comment, that job comment is added to every single test we do. In fact, if I put a / in front of that comment, it will create a folder in LinkLive and put all my test results in that folder. This is a wonderful way to organize my test results within LinkLive. So here, I've put in a job comment of new office. So every single test I run, as long as that job comment is in there, will have new office in it. So I could do a filter in LinkLive on new office and boom, drill right down to those results. Here it shows that it was able to connect to LinkLive and it sent the test result. Now if I come over here and press the F2 button, which is right below comment, I can add in my own comment. So I can say it's this jack, this office, this floor, whatever I want. I can add that comment and that will be associated with that test record in LinkLive. Now, if I've associated an email address with this tester in LinkLive, every time it uploads the test, it will send me an email. Mike, I ran the test. Here's the results. So I could go into that email, reply with the comment, and use that to add the comment as well. It can be a little bit easier to type the comment in on something like your phone than it can be on the LinkRunner. But hey, that's up to you. So here I've pressed F2 and I'm going in and I'm typing in my comment. When I hit save, that comment will be uploaded to LinkLive. And as I mentioned right here, multiple comments can be added to a single record. So after I add this comment, I can hit F2 again, add another one, F2, add another one. So now I've added my comment. Right there, that's my test comment, IDF, rack 1, jack A1. Whatever my naming is that I've got on there, I can put that in there. So LinkLive. LinkLive is a free cloud-based service provided by NetAlly. You can go out to link-live.com and set up an account. From there, you can claim the tester. So and we'll touch on in here where we go in and click on claim. But what that will do is that will take that tester and associate it with that LinkLive organization. So anytime you run a test, it'll upload the results to that LinkLive organization. This is a fantastic way to keep track of your test result, make it very easy for others to see those results and generate reports. In fact, with this, we can take all these test results and use it to generate a comma-separated values file that could be opened in Excel. Now I have switch, I have port, I have speed, duplex, jack number. I've got documentation. And you didn't even really work very hard to do it. It's pretty cool. So under tools, we have a number of different settings in here. We have instrument settings, reflector, factory defaults, language, manage files, claim unit, and update firmware. Let's go ahead and take a quick look at these. Vlan, Mac, and proxy configuration. Did I mention that this supports 802.1q VLAN tags? This is a great way to validate that our VLAN is working properly. So here I could come in and say, I want to do VLAN 10. Let's give it a try. So we're going to flip over here to our tester. I expect that this is a VLAN trunk, that I have more than one VLAN on here. So I'm going to go to my home screen. I'm going to go down to Tools. I'm going to go up here to my VLAN configuration. And I'm going to turn that on, and I'm going to set this to VLAN 10. I'll hit save. I'll hit save. home, I'll run my auto test. So now, every frame being transmitted by my LinkRunner AT2000 is going out with a tag of VLAN 10. So right here, let's collapse our PoE. Right here I see I got an address of 10.0.0.209. Well, in my network, the 10.0.0 network is VLAN 10. It works. I was able to get an address out there on my VLAN. Now, here we see enable user-defined MAC. Why would I change the MAC address of my device? Why would I do that? Why would I need to change the MAC address? Because I want to test a DHCP reservation. So let's say I'm working in an environment where somebody contacts me and they say, Mike, I'm bringing this piece of equipment in, a MRI machine, and here's its MAC address. We need you to set up a static reservation. I kind of like static reservations because it allows me to change things like my DNS servers, default gateways information, without having to reconfigure the actual device. So they give me the MAC address, and I program that MAC address into my DNS or DHCP server. Now, I could use that S word again, right? Should. That should work. But if I want to be thorough, what I can do is go out to the jack where they're going to plug that MRI machine in, configure the MAC address of the MRI machine into my LinkRunner AT, enable user-defined MAC, and ensure that I'm getting the IP address I put into that reservation. That is how I can be definitive in making sure that things are going to work properly. So, pretty handy stuff. Great way to go in, and there's our MAC screen, great way to go in and validate that that DHCP is working. Proxy, in some cases, organizations, you may need to put in the port and user information for your proxy server to get out. Okay. So here we did a test through a proxy server, says link live via proxy. So in order to get out, we couldn't get straight out, we had to go through a proxy and send some authentication information. General configuration, well, here's where we can do things like set our reporting mode. Now, if our reporting mode is set to local, our test results are saved on the LinkRunner AT. We're going to need to connect that to our PC using a USB cable to get those results off. So we would connect it to the PC and we would run the LinkRunner AT Manager software on our PC. If we have this set to link live, which means we had to claim it to link live, our test results will be uploaded and we will not be able to save them locally. So this is a one or the other. If we set it to link live, they're uploaded to link live. If we set it to local, they're just saved locally. Cable, feeder meters, that's pretty self-explanatory. Auto power off. If this is enabled, it will automatically turn off 10 minutes after you've hit any buttons on the screen. And we've got our date and time that we can set in there. It's always a good idea. Now these are some older screenshots. It's really not 2017. This is a great thing. I always like to check my date and time before I go out and start doing my testing so that it's correct in all my test results, because that's going to be burned into that test result. So before you go out and start working with this, it's a good idea to check the date and time, make sure those are correct so that you're not putting the wrong date and time into your test results. Reflector. If I'm using this in combination with an Etherscope NXG or a LinkRunner 10 gig, these two tools have the capability of doing performance tests where I'm sending traffic through the network and I'm doing a throughput test. When I do that throughput test, I need an endpoint, and this can act as a reflector. So if I put this into reflector mode, what it's going to do is it's going to receive the packets from the Etherscope NXG, It's going to flip them around and it's going to send them right back the other way. So what I will do is if I go into Tools and I select Reflector, I get this screen right here. Now right now it's showing me that it got an IP address, and this is the IP address I would specify in my configuration on the Etherscope NXG. It's telling me it's looking for packets that match the MAC address of the LinkRunner AT and have a packet type of NetAlly performance. It's going to flop the MAC address and IP and send those back out again. Now, we can go in and configure this. We could say packet type all. Ooh, this is dangerous. Now, one of the features that's available on the Etherscope NXG and on the LinkRunner 10 gig is the BERT test. Now, if I want to do a BERT test and use the LinkRunner AT 2000 as a far-end device, I will need to set this to all. So it's going to take any packet coming at it from the Etherscope or the LinkRunner AT, LinkRunner 10 gig, it's going to flip it around, send it right back. Otherwise, do not ever use all. This will cause a broadcast storm on your network and take down your network. I recommend just leave this at MAC plus NetAlly and swap MAC plus IP. Okay? So, if you're using it as an endpoint for a LAN BERT test, you're going to need to select all. Otherwise, leave it at MAC plus NetAlly. And if you're going to use it for LAN BERT and set it to plus all, make sure you put that back before you ever hit start on here. Our swap, here is swapping the MAC and the IP address. LinkRunner information. This gives us some information about our LinkRunner. So it's going to give us our serial number, our MAC, our software version, our build. And in this case, it's going to tell me some information about the SFP. So this is the SFP I have in there. It's a 1000 base SX SFP, multi-mode. A little bit of info, but what we see is that this particular SFP gave us our optical signal strength. So that's a pretty good little SFP to use. Managing files. So there's a few files that we may want to go in and manage on there. So if I select Manage Files, here is where I can load or save a profile. My profile allows me to save all my configuration settings, so I don't have to go back and redo those. So like right now I have it set to VLAN 10. So I could save this as a profile for VLAN 10. So if I want to test VLAN 10, I just load it. So this is where I can load and save profiles. So let's go back. Before we leave this screen, this is where we can go in and rename reports or delete reports. So if I'm saving my reports locally, this is where I can go in and manage those report files. Claiming a unit. If you have a LinkRunner AT, sign up for Link Live. It's a great way to manage your test results. So what you do is go out and set up your Link Live organization. And it'll pop a screen right up and say, hey, do you want to claim one of the units? Select the LinkRunner AT. This will show us what our MAC address is. Here we see we have an IP. So if we hit claim, this will start sending packets to Link Live. In Link Live, we will give it the last 6 digits of the MAC address. So in Link Live, we would put in B7187B. Don't put that in on yours. Don't try and claim my unit. Put your MAC address in. But when you do that, it'll claim that and it'll associate that LinkRunner right there with your Link Live account. So now the results will be sent up and loaded into that Link Live organization. Restore factory defaults. If you just want to set everything back to factory defaults, we can choose that. And if you're moving from one client site to another and you want to make sure you don't accidentally put the job comment in and things like that, this is a great place to do that. Firmware update. From time to time, we'll want to update the firmware on our LinkRunner AT. To do this, and I just went through this on one of mine yesterday, what you're going to do is you're going to download the LinkRunner AT Manager from the NetAlly website. Then you're going to go into Link Live. And to get the latest firmware, you need to have Ally Care support on your LinkRunner AT. So you can go in to Link Live, you can go into your administration menu, and it gives you a place where you can download the software. And you're going to need to put in your serial number so that you can download that new version. You're then going to download that new version onto your PC that has LinkWare AT Manager software on it. You'll connect the LinkRunner AT to your PC. You'll go into Firmware Tools, Firmware Update, and press Update. It'll listen. You go into the LinkRunner AT Manager software, select the update file, push that file over. Supports a few different languages. If you want to change the language, you can go into Tools and Set Language and change which language you're using. So here's LinkRunner AT Manager. So this is the companion software that works with the LinkRunner AT. It's free. You can download it from the NetAlly website. This allows us to do things like copy test results off the LinkRunner AT, generate reports based on those results, save the test results to our PC, manage profiles, create profiles. If you don't want to go through and type everything in on the LinkRunner AT, create the profile in here and push it over to the LinkRunner AT. Here's where we can put in our 802.1x authentication information. We can upgrade the firmware, and all the screen images that I used in this presentation were captured using this program. So here we have connected to our LinkRunner AT2000. I see that I've got a report in there. When I click on it, this shows me all the information for that report. It gives me that auto test information in a format now that I could export, I could create my test results, etc. in there. Profile Manager, we can save profiles to our PC. We can push them over to the LinkRunner. So this is a nice way that if I have a number of different clients I'm working with, I have static IP addresses, things like that, I can store those on my PC and move those profiles over that I need for a particular job. Great way to back those profiles up. 802.1x authentication. I can come in, I can set my security type, I can load my certificates up. This is where I go in and configure my 802.1x. Now, on the LinkRunner AT, the same 802.1x credentials are used for all profiles. So there's only one set of credentials that can be loaded, and that set is used across all of the different profiles. So here's our firmware update again. We'll go into update firmware in LinkRunner AT Manager. We'll select that update file. We'll go into the LinkRunner AT, press update. It will transfer that file over to the LinkRunner AT and update it. And that's about it. I mean, that's a lot of information to cover. It is an incredibly powerful piece of equipment. And as you see, we can use it for doing our wire map. We can use it for testing our switches to make sure that we have a good switch connection, that we're getting the optical signal from that switch. It's going to decode that CDP and LLDP information and let us know which switch we're connected to, which port we're connected to. With the auto test, fantastic way to go in and validate that the connection that we're hooked up to is giving us an IP address, a default gateway we can get to, DNS servers, and we can get out to those targets. And if you have that LinkRunner AT2000, you're going to be able to test PoE and draw current so we know that that device that we're connected to is providing the level of power that we need. So thank you for joining me for this training. Be sure to go out to netally.com and check out the other training resources that are available. And if you have one of these tools and you haven't set up Link Live, the first thing I'd like you to do when you get done watching this training is go out and set up Link Live. So thanks again, and hopefully we'll see you in another training.